Hello everyone, this is our first DIY team project and we have made smart irrigation system. Our team members include Janki Ratna Lakshmi Kusumanchi, Shreya Kumari, Shivansh Gandhi and Begari Om Prakash. We have made a smart irrigation system. In the absence of residents of a home, it is necessary to have an automatic system to keep the indoor plants well irrigated. For this purpose, we need an irrigation system which will be smart, that is able to monitor the level of soil moisture using sensors, and when the reading is below a threshold, it should trigger a small pump to carry water stored in a small tank to sprinkle on the plants and the soil until the moisture level reaches optimal level.
We have used Arduino Uno as our microcontroller. First, we connected the control sensor, so we connected. So we first connected the VCC to 5 volt supply of Arduino and then ground to ground. Then we take S0 of color sensor and that connected to 6th digital of Arduino. Then S1 color sensor to 7th digital pin of Arduino. S2 to 9th digital pin of Arduino. S3 to 8th digital pin of Arduino, and then we take out the color sensor and connect that to the 10 digital pin of Arduino. Second, we take the LCD screen. First, we connect that to VSS to ground, then VDD to 5 volt supply. Then we connect that Vino controls the contrast to 10K potentiometer. Then RS pin of LCD to 12 digital pin of Arduino, and then RW pin to ground. If RW pin is connected to ground, then Arduino will write in LCD. Then E enable pin, which enable the writing on Arduino to 11 pin of Arduino. Then we connect the data bus pin D4, D5, D6 and D7 of LCD to 1, 4, 3 2 pins of Arduino respectively. Then A anode of LED, OD LCD to 5 volt supply. Lastly, we connect that C cathode of LCD to ground through 220 ohm resistor. Third, we connect that soil sensor. First, we connected VCC to 5 volt ground to ground pin. Then we take the analog read pin of soil moisture and connect that to A0 pin of Arduino. We would not connect the digital pin of soil moisture sensor as we already take the signal from analog pin sensor. Fourth, we connect the servo. The red color wire of servo to the 5 volt supply, brown wire to ground, orange wire connected to 5 pin of Arduino. DC pump. First, we would connect VCC to 5 volt, GND to ground, then input pin of relay to 13 pin of Arduino, which would use it to turn on and off relay. Then we would connect the NO normal open pin of relay and connect that to negative terminal of motor, and connect that common pin of relay negative terminal of adapter, and connect that positive terminal of both monitor and adapter together. Then we would reconnect the buzzer and relay with appropriate sensors. Thank you.
I will explain the working of our model. First, the color sensor detects the color of the leaves as red or yellow or green. After detecting the color, the soil moisture sensor is activated. It detects the moisture level of the soil. When the moisture level in the soil is between the range 40 to 80%, green color is detected, else yellow. The soil moisture sensor then activates itself, due to which the relay turns on. The motor is then switched on, powered by the adapter. As soon as the moisture level reaches 80%, the motor is turned off. The LCD screen displays the color of the leaves and the moisture level of the soil. Also, LEDs glow according to the color of the leaves. If moisture level in the soil is lesser than 40%, the buzzer rings and the motor turns on. We have used servo for pouring in the fertilizer according to the color of the leaf. After completing the whole set of process, the system goes to sleep for 24 hours and then again the same process is repeated. Thank you.
So now we have discussed the code. First of all, I have included the liquid crystal and servo header files for using LCD and servo motor. Then I have defined these pins for using the color sensor, and I have defined these pins for different uses. Then I have initialized the liquid crystal display, and this is the red frequency, the value which would be taken from the color sensor. Then I have begin the LCD, and these are the pin modes for which pin is output or which pin is input. Then I have initialized S0 to high and S1 to low. These pins are of color sensor, so because of which its frequency scaling is 20%, which is ideal for Arduino Uno. I have attached servo to 5th pin. Then I have read the output value from the sensor pin, which is A0 for soil moisture sensor. Then I have mapped those values. So 550 being 0% moisture and 10 being 100% moisture. These are the value of resistance for the soil moisture sensor. Then I would start reading the color sensor. So if S2 and S3 are low, then it would read the red color. The photodiode of the color sensor would read red color. So red frequency is equal to pulse in. So pulse in is used to measure the frequency. So first of all, we use red color to map those frequency. In similar fashion, we first write S2 and S3 high, which would activate the green part of the photodiode, and in similar fashion we map those values using pulse in function. Then S2 is low and S3 is low for blue, for activating the blue filter of the color sensor. So I have mapped these values from 255 to 0, 38 being 255 and 84 being 0. So for using we have mapped these values because we have to use RGB coding. So we have used the RGB coding. So this is the yellow color coding. So first of all, cursor would be set and it would print moisture and it would print yellow leaves since this is the yellow color. And then it would initialize the soil moisture sensor. So if this output value is this, then the motor will turn on, else it would turn off. Similarly, this is for the green color and this is for the red color. And this is the code for the servo for controlling the fertilizer. We have used this is the code for servo motor. We have used this yellow color depending upon the color sensor. So I have used this my servo. So this is the this is yellow color. So this would be the code for the servo motor, and this is for the green color, and this is for the red color. Then it would delay for 24 hours. I have used this value after converting 24 hours into number of milliseconds.
And this is our final code, and now we would upload it. So as you can see, this is the code which we are going to upload, and now I am going to press the upload button. As you can see, the code has been uploading and the code has been uploaded. Now we would go to final demonstration. As you can see, this is the color sensor TS3200 which we have used. This color sensor has 4 LEDs, as you can see, which will reflect the color from an object, and after reflecting, the light would go on to the centerpiece, which is the photodiode, which will sense the color. It has four types of filters: a red, green, blue, and a clear filter, which will record the frequency and give us the color using the code. And now we will show the working of the color sensor. Before testing the color sensor, we would place the soil moisture sensor in the water so it does not turn on the motor. Now we would place a green color in front of color sensor and the green LED is glowing. And the corresponding output you can see in the serial monitor, the color of the leaves is green. Now we would place a yellow object in front of the color sensor and corresponding yellow LED is glowing. And you can see the corresponding color of the leaves in the serial monitor also. As you can see, now we will place the color sensor in front of a red color. As you can see, now the red LED is turned on, and you can see the corresponding output in the serial monitor. Serial monitor is printing red, color of the leaves is red. Now we would place the soil moisture sensor in the soil so as to read the soil moisture level. So the soil moisture sensor works on the principle of variable resistance. As you can see, when the soil moisture sensor is in air or no moisture, the resistance of soil moisture is very high, so the current cannot pass. But when it's in the water or in the presence of moisture, the resistance becomes lower and it let the current pass, thereby giving the signal to the Arduino to turn on the motor. Now we would place a black cloth in front of the color sensor, which will turn off the color sensor. So the color sensor would not be able to sense red, yellow and green color, because of which the motor wouldn't turn on. But the soil moisture would work, giving us the current moisture level of the soil. Since the soil moisture, despite the soil moisture being working, the motor wouldn't turn off since the color sensor is turned off.
Now as you can see, the current moisture level of soil is 60%, which is indicated by the soil moisture sensor.
Now we would remove the black cloth from the front of the color sensor, and we would place the leaf so that the color of the leaf would be sensed by the color sensor. So the green LED is turned on, which indicates the color of the leaves is green. Now as you can see, the serial monitor is also showing the color of the leaves is green. And now we'll insert the pipe. Since the soil moisture sensor is sensing low moisture, so the motor will turn on. As you can see, water is filling up, and after some time it's turned off. Motor is turned off.
So now for the output of DC motor, as you can see, the moisture is 60% and it gradually increases and goes up to 80%. Then there's the message that the motor is turned off and water level is reached up to 80% will pop up.
So the buzzer would turn on if the soil moisture goes below 40%, and since the soil moisture sensor is in the air, the buzzer will turn on. For fertilizing the plant, we have used the servo motor and a plastic cup. As you can see, the plastic cup is pivoted at the top end, and the servo motor is connected at the bottom end of the glass. To pour the fertilizer, there would be a tap at the bottom, because of which the glass will tilt and the fertilizer will pour. But after every use, the amount of fertilizer will decrease. So to encounter this problem, what we have done is, the for the first tap, the servo motor would rotate 10 degrees, but for the second tap, the servo motor would rotate 20 degrees, and subsequently the servo motor would rotate 30, 40 up to 180 degrees. After 180 degrees, the cup will be empty and the servo would reset back to 10 degrees. So we have to refill the cup with fertilizer once again. You can see here, we have poured the some amount of water in it to demonstrate, and there would be a tab because of which some amount of fertilizer would pour. And this was the whole video for our DIY project. Thank you for watching.